Hello everyone. In today's class, let us start discussion about connected bodies. In the Newton's laws of motion, connected bodies part, let us start discussion. Okay, na? First one, blocks connected by a string. Here there are three blocks M1, M2, M3. Okay, na? These are connected with a string and it is being pulled with a force F. So in this case, string is massless, right? That is first point. And here M1, M2, M3 and placed on the smooth surface. This concept completely we discuss without friction floor. Okay, na? So means this system of blocks are placed on smooth surface. Now we need to find out the tensions in the ropes, rope connected part M1, M2 and rope connected part M2, M3. So what is the tension in these ropes? We need to find out. So let us start solving the question by using the Newton's laws of motion application here. F net acting on the system we need to find first, and how much acceleration with which they can move. Then after we can apply the net force equation for each body. Okay. So let us start discussion here. So first of all, we can write down Newton's second law of motion explains F equals to ma. Okay. So from this F equal to ma, we can write down what is the mass of the system, means total mass and total force we need to write. So for this one, F equals to m1 plus m2 plus m3 into acceleration. See once again, F equals to m1 plus m2 plus m3 into acceleration, means the total system is moving right side with an acceleration a. For this case, we can apply this equation. Okay, na? Then acceleration value equals to F upon total mass m1 plus m2 plus m3. So this is the answer for what total acceleration of the system of bodies. Now come to one object, apply the net force equation. Let us consider here first concept or first part of the question, how to solve. So we find first of all this tension T2 which is connected between M1 and M2. Then we need to take the reference of M1 only. Here M1 block, and it is connected with the string which is connected for the next block M2. But from here only we can take a part separate. Though this is the point of contact and right side T2, already in the figure it is given T2, so that's what I am also taking T2 only. Okay, T2. And any other force act to backward means no. So it is placed on rough surface, not rough surface, placed on smooth surface. So backward force not there, means friction not there. So only right side force acts, and its acceleration right side must be a. Then what we can take, T2 equals to m1 a, and acceleration value we got already. That value we can substitute. T2 equals to m1 f upon m1 plus m2 plus m3. This is the tension part in the string which is connected between m1 and m2. Now second case, this block. So we will take the block of m2 here. So right side force acting is T1 and left side force is acting T2. But as a system total moving right side na. So now it is also move right side with acceleration a. So now right side moving acceleration means right side force should greater than the left side force. So now here you can check T1 minus T2 means net force equal to mass into acceleration m2 into a. So we want actually T1 is the force because we know already T2, and you don't get confused here. This string is connected for m1 and m2, so string is same, the tension is same. Sir, here M2 block na, then different force might be. No, definitely the string is one then tension must be same only. But the direction of this one will be different. Okay, on M2 it is left side, on M1 it is right side. That's it. Okay, now here we need to get T1. So T1 equals to T2 plus M2A. So I am simple purpose just getting this equation to be substitute here. T2 equals to M1A. I could substitute here T2 as M1A. So T1 equals to M1A plus M2A. A should be taken common, and then finally T1 equals to M1 plus M2 into A, and which explains acceleration value from the equation 1 we can substitute now. So A value F by M1 plus M2 plus M3. This is T1. Okay, and here whatever the force is being acting on this system, okay, this is F right side, right, and left side how much? T1. But T1 we know, F also we can know, that is from here we can write down F equals to this much only, right. So F value we can find out from here. That is enough to write down this equation. Okay na? And the values of M1, M2, M3 given as numerical, and just simply you can start the question from the last mass. Suppose force is applying this side, then you start from this block. And suppose force is applying from right side, then you start the question from left side. It is easy to solve in this way. Okay. So next slide we will see. Here the numerical part of the same question, means just numerical, same model. Figure shows 3 blocks connected by a light inextensible string, a pulling force of 20 newtons. Here it is 20 newtons acting right side, applied on the 2 kg block. Okay, find the tension in the string connecting the 3 blocks, means here they are asking tension part in different cases. Okay, so let us consider this is the diagram. So 20 Newton applying right side, A, B, C blocks masses are given already. So first we need to take what? Total force equal to total mass into acceleration. So that purpose they have given here. Total mass is kept in a box, that is means we need to imagine these 3 masses as a system, initial case. So here you can check F net equals to M into AX. F net is acting how much? 20 newtons. 5 plus 3 plus 2, how much here? 10 mass, means mass total 10 kg into acceleration. So we can write here acceleration 2 meter per second square. This is answer for acceleration. Okay. So now for this case they want to solve here. Means they have started from the right side only, there is no issue. If you start from left side, it will become very easy actually. Okay na? So here this one, they took these 2 bodies as a system. Okay na? Then we don't get any problem about this tension. That way also we can solve. So right side force on this 2 block system is T1, and left side no force because it is placed on smooth surface. So what is the mass? 5 plus 3, 8 kg. 8 kg is being pulled by T1. You can see T1 equals to 8 into A. What already we got A value here, 8 to the 16. We get 16 newtons in the string which is connected between 3 and 2 kg block. Next in the last part of the string, here T2 acts on the 5 kg block. So T2 equals to what? 5 into A, where A equal to 2 meter per second. So 5 into 2, 10 newtons. Like this we can solve simply. Okay na? So this is the way the question we can able to solve. Next. The same system, but it is placed on the inclined plane. Okay. So let us see. Figure shows 3 blocks connected by light inextensible string. A pulling force of 100 newtons. Here 100 newtons force is applying right side, means upside the plane. Here it is they have taken as x-axis and perpendicular to inclined plane taken as y-axis. So now applied on the 2 kg block, the first one is 2 kg, and find the ratio of tensions in the strings connecting the three blacks means they are asking these three blacks means here one tension, here one tension. Their ratio they are asking. Okay. First of all, what we need to do generally, total force equal to total mass into acceleration. Same concept we can solve. Okay na? Let us start from here. This is the first answer figure. So three blocks taken as system. Okay na? Right side force, left side force. Sir, they just before in the slide you don't say any left side force na. But here how can you take? Here one component will come downward the plane. In the previous case it is in horizontal direction, so backside no force. But here they have a chance to slide down with a force of mg sin theta each block. So you can just check out total mass downward, total mg force downward, and mg sin theta comes along this one, and here mg cos theta will come. Mg cos theta balances what normal force in the previous sections we discussed. And here upward force, how much it is applied? 100 newtons. Okay. So now it is going right side only, 100 minus. Here in this case downward, how much? 2g sine, angle is given 53, and here 3g sine 53, and here 5g sine 53. Okay. So just we can see here it is 5g and it is 53. So total downward force 5g, 3g, 2g, and every value is component of sine only. So 5, 3, 2, 10g sine 53. It's downward. Okay na? So you can check. F net along x-axis means they already just now I told, along the plane they took as x-axis and perpendicular to plane they took as y-axis. So 100 is upward force 100, and downward force mass A, mass B, mass C into g sine 53, just now I told. So total value is become 10 and g value 10, sine 53 4 by 5 equal to 10 into A. Here right side total mass only, so we don't take any component mass, we can take directly 5 plus 3 plus 2, 10 kg. So 10 into acceleration. On simplifying here, 5 2s are. So this much 2 4s are 8, 8 10s are 80. 100 minus 80, how much? 20. So we can take acceleration 2 meter per second square. Okay. So here after that, for the tension 1 we need to find. In the second case, you can check. These two blocks taken as a system, and right side in this connected portion T1 string will be, means T1 will be acting this string. So T1 and left side force, these two blocks weight component. Okay, what is 5g sine 53, 3g sine 53 acts downward, right? So let us see, T1 minus downward force means down the plane force, MA plus MBg sine 53, and here total mass we don't take, only the masses which comes as a system. Okay, here T1 is acting on the system of 5 plus 3 kg block, so we can solve like that. So MA plus MB into AX, and here 5 1s are 5 2s are. Here how much? 2 4s 8, 8 8 is 64. 64 shifting on right side become plus. But here what? 5 plus 3. This is 5 kg. This is 3. 5 plus 3 kg 8. 8 into 2. Because acceleration we got already 2 meter per second square. 8 2 is 16. So 16 plus 64 here it comes 80 newtons. The string connected between what? 3 kg and 2 kg value will be 80 newtons. And later on portion it is last block 5 kg as a system, and upward T2 will be active from this point, and downward how much force act here means 5g sine 53. So you can check T2 upward minus downward force mg sine 53 equal to ma. So mass of the block is 5, here 5 cancel, this is 40, and here 5 2 is 10, so 40 plus 10 50. And if you take T1 is to T2, 8 is to 5, because they asked the ratio of tensions only. Okay na? This is the way we can solve simply. Next, vertical motion of the block. Okay, see, here is the system first. M1, M2 are connected with the help of string and it is being pulled with a force F upward, vertically upward direction. But in this case, you can check with respect to this one, tension acts downward. With respect to this one, tension acts upward, but the tension will be same because in the same rope. Okay. So now we can solve one diagram, one block by one block means free body diagram. First we need to solve, first we need to draw, then after F net equation, then after we solve for the tension values. Okay. So let us see first of all free body diagram of what M2 block. So M2 block downward force is M2G and upward acceleration same only AY only, and here just now I told you this is the tension force upward direction, so tension upward and it is going upward na. F net equation how to write upward force minus downward force. Okay, T minus M2G equal to M2A. So T equal to M2 into G plus A. This G plus A is taken as G effective here especially. Okay, that might be G plus A, that might be G minus A sometimes depending on the motion of the blocks. If it is go downward, it will be taken as G minus A. In the coming slides, we will discuss. Okay, next M1 block. For M1 block, downward force is tension and downward weight force also there, upward force is there, F applied force, and it is going upward. So now we can write total upward force minus total downward force. Total upward F minus M1G minus T equal to M1A. So simply we can write down F equal to M1 and here tension value how much? We got already how much here? M2 into G effective we got. Okay. So we can just make you sure that how to solve this one. Here M1 if shifting on right side, F minus, I am keeping T here only and just I am shifting right side M1G. This is minus na, on going right side it become plus only. So G plus A. Now what we can write G plus A, what we have taken? G effective, which means M1 G effective right side will come. But T equal to already how much? M2 G effective na. So we can substitute here, this is M2 G effective and shifting on right side M1 plus M2 G effective. That is we get the answer for force acting on the system of the blocks. Okay na? So here only just we have written the value of G plus A as G effective. Okay. So don't get confused. Just let me solve that once again. You can see F minus T equal to M1 into G plus A. I am solving the same once again for I am not getting any problem. Okay na? So just I am solving for you. See here once again. T value how much we can take? Minus M2 G plus A equal to M1 into G plus A. So shifting on right side, F equals to, this G plus A will common na? So we can take M1 plus M2 into G plus A, and this G plus A we can take as G effective. Finally, M1 plus M2 into G effective. That is the force which is applied on the system to pull upward with a given acceleration AY. Okay na? So for clarity purpose only I have solved here. Whoever got in the first step only, no problem. And for not clarity getting persons, just you can see this one also and we get an idea how to get this answer. Okay na? Thank you. Next, downward direction. Same concept sir, but it is going downward direction. Here two blocks again, M1, M2 only, and F is applied upward, but it is going downward direction. Okay na? So let us see M2 block, downward force M2G, upward T and downward acceleration A. Now it is going downward. So since a downward force should be taken as greater only na, so we can write M2G minus T equal to M2AY. So we can write F net equation. Then after t equal to this one shifting on here, it become minus, it become plus. So g minus ay we can get, just now I told you in some cases it will come g minus a also, that is in downward direction. So we get here g effective as g minus a. Next for the M1 black, okay, so downward force weight and downward force tension T, because here it is connected part. So with respect to this downward, how much force? Tension T. Now here tension T acts and upward force how much beta? F acts. So total downward force minus total upward force, because acceleration is downward, right? So total downward force minus total upward force equal to M1ay. So tension value again we can substitute from here, that is M2 into G minus A directly, and substituting here we can simplify M1 plus M2 into G minus A, that is G minus A taken as G effective, okay na? So here in this case, when we are applying force on the system, upward only, but it is going down, means force applied upward direction, but the system is lowered like this, okay. So it is just with how much force it can be applied to move with this much acceleration, we can solve this answer, okay. Next, here is the question based on the same concept, right? 3 blocks are suspended by a light string as shown in the figure below. What is the value of T1, T2, T3? 3 tensions they are asking to find. Whole system is moving up with an acceleration of 2 meter per second square. This entire system is moving up with an acceleration 2 meter per second square. Then T1, T2, T3. T1, T2, T3 we need to find. Okay na? So let us. Here data given 1.5, 1.5 and 4 kg and acceleration given. So first T3. So T3 just now I told you na, last block onwards we can start. So you can check T3 means 4 kg block. You can see here 4 kg block, downward force 4g, we can write simply 4g, and upward force T3. So it is going upward na. So then we can write T3 minus 4g equal to 4a. We can take. So you can write T3 minus 4g equal to 4a. T3 equal to 4g plus 4a, that is 4 into g plus a. We got the same, right? Answer 4, here g value 10 and a value how much? 2. Okay na? So 4 into 10 plus 2, which is 12 into 4, 48 newtons it will come, okay. So 48 newtons come. Next second block we need to check. This is second block we can take. For the second block you might see downward force, because it is connected for this one only na. So T3 will act downward. Next is its weight, that is M2G we can take, otherwise 1.5G. And here in this case, this given here it is string tension T2. So upward T2. Since it is going upward only na, so we can take upward force minus downward force. You can see T2 minus of T3 minus M2G equal to M2A, right? But T3 value we already got. Directly we can write. Okay na? So simply we can solve for this one. T2 minus T3 M2G minus M2G equal to M2A. T2 equals to T3 plus M2 into G plus A. Okay. So T3 value how much we can write generally? Here 4 into G plus A only na. Okay. So same answer we can write here, that is 4 plus M2 into G plus A. This is. So that is 4 plus 1.5 here into 12. G plus A 12 we can take. Here 5.5 will come na. 4 plus 1.5, 5.5. So 5.5 into 12 we get here answer is 66 newtons. Okay na? That is we got. Next last one, what is T1 they are asking. So T1 they are asking means this is T1 in the upward string T1 and downward force. Downward force is what is connected here, T2 string is connected. So we can have T2 downward and its weight force is M1G downward. Okay. So then total upward force minus downward force equal to mass into acceleration we can write, that is T1 minus T2 minus M1G equal to M1A, that is T1 equal to T2 plus M1 into G plus A. So here it is 66 we got, this is T2 only na. So T2 equal to 66 we got already. Okay, this is now from there here M1 means 1.5 into 12. Okay na. So here it is total answer we can get as 84 newtons. Okay. On adding and multiplying and adding we get 84 newtons. That is what how we can find out tensions in the each of the block. Okay na. Next. Here steps to solving the pulley questions means connected bodies only, but pulley model questions, actually it is also called Atwood's machine. Okay na, Atwood's machine. First of all we can take step 1, assume the direction of acceleration and draw FBD for all masses if required. Resolve the forces along the axis. Generally, if any angular position the block can move, then resolving the forces is necessary. Otherwise, we can have first two conditions only maximum in all cases. So that is assume direction. Suppose it is going downward means it is going upward. Otherwise, it is going upward means it is going downward. Otherwise, here masses you know, for suppose it is 5 kg, it is 2 kg. Then it will go downward, it will go upward. That we can find out easily, right? And draw FBD for all masses. How many masses are there? Then for them, we need to draw the free body diagram. So let us see. Here downward M1G for M1 block. Upward here it is connected part, no? So here acts tension T. At the same time, here it is acts tension T because rope is same. So tension must be same. Okay. So let us see M1 first of all. Here downward how much? M1G, upward T, and here it is taken upward, it is going with acceleration A1. Okay na? So next here M2. For M2 downward weight force M2G and upward T tension, and as it is going upward then it must be go downward with acceleration A2. So next write the equations using Newton's second law along each axis for each block. Just we need to apply F-net equations for the cases here. Okay na? So that is F-net equations we need to solve. So first of all let us take consideration here. So what is the force acting? Means acceleration upward na. So T minus M1G. T minus M1G equal to M1 A1 they take. Next here M2G downward, and because it is going downward only, so M2G more force. Okay. M2G acts downward generally weight force, but it is more because its acceleration is downward. So M2G minus T equal to M2A2. So we need to solve these two equations generally. Okay na? So now first of all we have taken its acceleration A1, its acceleration A2. So we need to confirm that whether A1 equal to A2 or not. If it is yes, then A1 equal to A2 we can put in the equation and we can simplify. So for this case you can see, suppose we can assume it gone by x meters upward, then it lose by x meter same, then it will go by x meter, which means its displacement x, M2 displacement also x. Suppose its velocity v, then definitely its velocity also v. So then similarly its acceleration a, then M2 acceleration also a. And this is one method to solve A1 equal to A2. Otherwise one more concept also I discussed in the previous class, that is what is the force acting on the M1. So we can simply T into x1, so it is going upward, and here minus because tension upward it is going downward na. So we can take T into x2 equal to 0 because total work done by the string in all the block subsystem equal to 0. We discussed it in the constraint relations. So T x1 equal to T x2, where T cancel, x1 equal to x2, it gives you a1 equals to a2. That's it we get here. Okay, na? Now these two equations we have to solve, right? How to solve that equations? Let us see here only, right? So let me write the equations here. First of all, T minus m1g equal to m1a. a1 equal to a2, na? Just I am writing a only for a1 and a2. Next to second equation, m2g minus t equal to m2a. On adding only, simply we can take m2g minus m1g equal to m1 plus m2 into a. So acceleration equal to m1 plus m2. You can see here m2 minus m1g by m1 plus m2. This is the acceleration answer. Okay, na? And this acceleration answer, if we substitute in any one of the equation, which means equation 1 or equation 2, we get a tension value. Okay, na? The tension value we can solve here by substitution of acceleration in the above any one of the equation. You will get this answer 2m1 m2 g by m1 plus m2. We get this answer. Okay, right. Next, one more condition also we can solve, that is, here space is not present. So simply this is suspended point, okay, na, for the pulley, and here two parts of the string. Here it is downward with respect to this point, with respect to this point also downward. Okay, so here it is suspension point, with respect to this suspension point downward, and with respect to this pulley upward reaction force, suppose, and this reaction force equal to how much? 2T for the balancing of pulley. So this reaction force exerted by the pulley mass system on the roof. Okay, so R equal to 2T, means here T already we got, into 2 if we do, na, then answer will be reaction force by the pulley mass system on the suspension, point of suspension we get. Okay, so next, here same question, concept same only, but question they have given here 2 kg and 3 kg block given. Okay, so after the blocks are released, they kept at rest first initially and released. So then calculate the acceleration of the system and amount of tension in the string. So in the single string and blocks cases, acceleration of both the blocks must be same. Just now we have discussed in the previous slide. So 3 kg will go downward definitely, then 2 kg will go upward. So you can see for 2 kg free body diagram, 2g downward, upward tension T, with respect to this point tension will be T. So T upward, acceleration also upward, and for 3 kg downward weight force, and with respect to this point tension will be upward. Okay, so now acceleration direction depending on, we need to write the second law, net force equation by using second law of motion. That is, you can check first one, what here T minus 2g, because it is going upward, T minus 2g equal to 2a, and next 3g minus t, 3g minus t equal to 3a, and tt cancel, 3g minus 2g, so we can take it g equal to 5a, a equal to g by 5, which is 2 meter per second square, and a value if you substitute in any one of the equation, we get tension, that is T minus 2g equal to 2a, means I am taking first equation. So T equal to 2g plus 2 into 2, here 20 plus 4, which is 24 newtons. This is the tension acting, and since a single string is there and same tension acts, and tension will be same in the total string. Okay, this is actually first method, and second method is also very easy, that is supporting force minus opposing force by total mass equal to acceleration. Okay, na? Supporting force means in which direction it is going, that force with which it is actually pulled, that force minus opposing force. You can see when we release both the blocks, 3 kg go down, 2 kg moving up. So 3 kg go down means 3g what doing here? Supporting only, and 2g acting downward, but it is going upward. So opposing force how much? 2g. So we can take here, this is 3g minus 2g by total mass 3 plus 2 5. So 3g is 30 minus 20. So simply we can take a okay 10, that is 10 by 5, which explains 2. This is the answer we can get. Then after we can just write down same 2 value in the any one of the free body diagram using any one of block free body diagram using, we need to write net force equation. Okay na? So in that net force equation you substitute this acceleration. So to get tension definitely, or to find the tension value, definitely we required one net force equation minimum, and acceleration we can solve easily. Okay na? So after getting acceleration you just try to write net force equation for any one of the body if tension is same in the total string. Okay, if tension is same in total string, then you can just write one net force equation, right? This is the way we can solve. Next, here just small modification in the concept, that is one block is placed on the table, one is living in the just air. So here a block A of mass 7 kg placed on the frictionless table, means smooth table, a thread is tied to it and passes over a frictionless pulley and carries a body B of mass 3 kg. At the other end, the acceleration of the system, assume table to be smooth and take g equal to 10 meter per second square. Once it is released, then it is tried to pull down and it is tried to move forward. So first concept, what we can write the direction of acceleration, as it is go downward acceleration and as it is go right side acceleration, and the tension is same because only one string is there. So one string is there means it go by x, then it is also go by x, means acceleration of 3 kg and 7 kg must be same, not different. So A1 A2 same. Okay, now net force equation we have to write. So net force equation for 3 kg, let us see downward force 3g, upward force t, and downward acceleration, so 3g minus t equal to a. Here they are using what is supporting force minus opposing force by total mass, okay na, to get the acceleration. Let us solve by first method only. Okay, so let me take 3g minus t equal to 3a, right? Next, what is the net force? Free body diagram for 7 kg, right side force t and left side force nothing. So we can write simply t equals to 7a. This 7a we can put up in the place of t. So that is 3g minus 7a equal to 3a, which is 3g equal to 10a, 0 0 cancel, a equal to 3 meter per second square. You get the same answer. By any method also you get same answer. Okay na? But this is somehow easy to find out the tension. Okay na? Only acceleration they have asked, so acceleration answer done. But suppose if the extension is asked and after getting acceleration you need to write net force equation for any one of the body, and it is very simple. If you substitute a value here, you get tension answer. That is T equal to 7 into 3, that is 21 newtons. Okay na, tension also we can able to find. And in this case one more advantage and one more way also they can ask you the question. Let us solve that one also. Even it is not asked in the question, we will solve. With respect to this pulley, downward force is T, and with respect to this point of the pulley, tension force is left side. So for pulley, if I draw free body diagram, this is T and this is also T, right? So in this direction net force will be there, and simply TT same, and here 45 degrees only should be present. The net force how much it will be? T square plus T square, because both the tension forces are separated by 90 degrees. So tension force it is. Force means vector quantity. So simply we can write root 2 into T. This is F net we can get, which is F net acting on the pulley root 2 into 21. This is 21 root 2 newtons. This way we can solve the answer for extension of the same question, like pulling force or just with how much force it can be pressed against the table. Okay, na? That pulley can be pressed against the table with how much force. We can solve by using this concept, right? Next, here figure shows 3 blocks of mass m, each hanging on a string passing over pulley. Calculate the tension in the string connecting A to B and B to C. So suppose we can take here, this is A, this is B, this is C. So we can write down with this one, this is A, B, C, okay. So let us first of all, here 2 masses are there, it go downward, it go upward. So in such case, we can solve first of all, acceleration equal to total supporting force. Supporting force means net acceleration downward here and net acceleration upward here. mg, 2 mg downward. So we can write simply 2 mg minus here opposing force mg divided by total mass 3m, which can be written as mg by 3m, which can be taken as g by 3 meter per second square. So tension to be find out, we generally in this string they are asking now, then only one net force equation required, but here also they asked no 2 more, means one equation and second two net force equations required for the C block. Okay, so let us solve for the C block. Right, C block m, here downward mg, upward tension T, like T1 you can take, and acceleration downward only. So simply net force equation mg minus T1 equals to ma. Okay, so T1 equals to mg minus ma, a value g by 3, mg minus mg by 3, which is 2 mg by 3. This is T1. Okay, and not to make much complicated, then you can solve from here also. Okay, na? Here also we get the answer for the second string how much tension will be x. So that tension also we can find out. Let us see by taking this block or by taking this block, that is up to you, right? So I am taking for block A. For A block, upward force is T2 and down, actually system is going upward, na? Right. Left side it is going upward, right side it is going downward. So acceleration upward and downward force mg. Then watch which force minus which force? T2 minus mg equal to ma, which is T2 equal to mg plus ma. A value how much? G by 3. So we can write 3 mg plus mg, 4 mg by 3. This is tension T2. Okay, na? So T1, T2, like this way we can estimate. Let us go to the next slide. Here it is a question, a man of mass 60 kg is standing on a weighing machine and kept in a box of mass 30 kg as shown in the diagram. If the man manages to keep the box stationary, find the reading of the weighing machine. Okay, actually reading of weighing machine is explained by reaction force. Okay, na? So we need to consider first of all free body diagram. So for person, at the same time here it is a standing in weighing machine kept in the box. Okay, now you can assume this is as completely box, right? So now let us consider the person. So for person, I am writing one tension upward and person weight downward, mass of person into g downward. Okay, and reaction force by the weighing machine or contact with the weighing machine, that is R upward. Actually R we need to find out. Okay, na? So and it is not going anywhere, actually it is manages to keep stationary, they said. So acceleration 0 means total upward force equal to total downward force. So we can write T plus R equal to mass of person into G, equation 1. Next, for box. For box we can solve like this. Box here, tension T, and box mass will act will give you weight force. So MBG downward, and reaction force on the block will be R downward. Here important point is the reaction force between person and box will be same, but with respect to person it is upward, with respect to box it is downward. So that is we need to take care in the solving of the question. So total again acceleration 0 for box also. So then T equals to R plus MBG. This is second equation. Suppose R we can keep like that. Mass of box how much? Here man of mass 60 kg and mass of box 30. So 30 G. This is tension. So let this equation is 2. So this tension value we can put up in the first equation. Why? Because you can see single rope is there, so tension must be same only, and here we have taken with respect to this is upward, and with respect to this person also upward tension. Okay na? So we can take for second equation value into first equation, that is T same. So we can write down first and second equation. Okay, so that is R plus 30G plus R. See, tension value R plus 30G plus R is there, equal to mass of person 60 G. So here R plus R 2R, and 60G minus 30G, here 30G will come. 2 1s are 2 15s are. R equal to 15G newtons, and we can take 150 newtons. This is the weight of the person. Okay, it is given by the weighing machine in this case, and you can put the value of R here. You can get the tension also. They did not ask, but you can find. Okay na? So from equation 2, T equals to 150 plus 300, because 30G is called 300. See, G value 10 I am taking. So 300, 400, finally 450 Newton acts in the rope. Okay, tension acts in the rope is 450 newtons. Let us move on to next slide. Same explanation only. Okay na? So it is not required. Here contact bodies. Two bodies kept in contact. Okay, so here it is applied with some force on the system. That is, here F is applied right side to move the blocks M1 and M2. Suppose we can take a why we need to discuss this condition. Let us see, two blocks are kept in contact and some force is acting on one of the block. Okay, means according to first law and second law, you can consider when force is acting on the system, then there is a cause of acceleration, otherwise change in the acceleration or change in the state takes place. So here force is acting on M1, but M2 also move along with M1 because it is kept in contact. Then M1 exert a contact force on M2, but actually external force directly not acting on M2. So this situation will take help for the solving of what generally, what is the contact force acting on M2 we need to consider or we need to find. Okay, so two body case we can discuss here first of all. So that is, we have seen here two blocks are there. You can see this is the diagram and here it is F acting. Okay na, on M2 there is a force acting by M1. How much force? Suppose you can consider R is the force. Okay, reaction force or contact force, you can take normal also, no problem. Okay, so you can check here, this is, we can write here, this is like R and here it is R. Why? Because with what force M1 exert on M2, the same force M2 also exert on M1. So definitely we can write down this is R, right? So before finding R value, we can solve first total system is moving together. with the same acceleration. So we can solve for acceleration. F equals to total mass into acceleration, that is acceleration equal to F by m1 plus m2. We get this answer. Now we can solve for the normal force or reaction force or contact force, that is from the second body. See, m2 is experiencing only force R, that's it. No other force it experiences. So definitely we can write here, this is m2 and right side reaction force is acting. So we can simply R equals to m2 into A we can write, where m2, A value how much? This much. F by, here we can take m1 plus m2. This is the reaction force which exert on the block m2. And suppose if 3 blocks are there, in the next slide we will see 3 blocks case. Let us see in the next one. Here 3 blocks are there and only m1 is being applied by force F, suppose. It is being applied by force F and the entire system is moving with acceleration A. Then in this case, what is the contact force between m1, m2 and m2, m3? We will solve. So that is first of all, total force equal to total mass into total acceleration. So acceleration equal to F by m1 plus m2 plus m3. Okay na? So now we will take first of all m1, m2 also you can take, otherwise m2, m3 also we can take. Okay. So let us take from the ending. So m3. So this is m3. Only reaction force exerted by m2. See, m2 exert reaction force on m3. Okay. So this reaction force we can take as what here you can see. This reaction force we can take it as so this is I am taking R1. Okay, beta. So this is R1 I am taking. So we can find out R1 value. How much is the R1? So we will solve for R1. Let us see. Here R1 is acting on the M3. So simply we can write down R1 equal to M3A because no more back forces. It exert force on the M2, that is secondary, but on this one backside force not there. Only right side force is there. So that's what R1 equal to M3 into F by M1 plus M2 plus M3. Okay. This is reaction force we can get. Next, between these two blocks, we can take R2. Suppose if I take this is R2. So we can find out R2 also. So before finding R2, M2 body free body diagram we can take. M2 block free body diagram. Okay. And it experience a force R2 right side and it experience a force R1 left side. But it is moving right side with acceleration. So definitely R2 is greater. So R2 minus R1 equal to M2A. R2 equals to R1 plus M2A. R1 value M3A na, so we can write here, that is M3 plus M2 into A, that is R2. Okay, final answer R2 equals to M1 plus M2. Acceleration value from here we can get F by M1 plus M2 plus M3. This is the answer. Okay. So reaction force exerted by M1 on M2, M2 on M1, R2, M2 on M3 or M3 on M2 will be R1. Like this we can solve. Next. Here same question given here, same concept. 3 masses 16 kg, 8 kg, 4 kg are placed in contact as shown. A force of 140 newtons applied on 4 kg mass. You can see 140 Newton is being applied on this one. We need to solve force on the 16 kg. Here this force they are asking. So we can find out here first of all this force to be taken as R. Okay. So that R need to be found, but before finding R, we need to take total force. equal to total mass into acceleration. So 140 equal to 16 plus 4, 20, 20 plus 8, 28 into acceleration. 14 twos are 14 tens are 2 ones, 2 fives. Acceleration equal to 5 meter per second square. Okay. Now 16 kg free body diagram we have to draw. That is here 16 kg and it is being experience a force R. So no other force acting on the 16 kg. So definitely R equal to 16 into A, 16 into 5, which is 80 newtons. Okay, na? So this is answer for the question, right? Next, rope with mass. So generally till now we have discussed about rope massless, but rope with mass, if it is pulled now, we can find out tension at any point. So that is we can do here. So consider here it is a rope, okay, and its mass is capital M, its length is L, it is being pulled with a force F, right? It is a rope actually, you can see, and they can ask you tension at any point of the string, right? You can assume that from here x distance, at this point they will ask you what is the tension at this point, right? We will solve the question. So according to Newton's second law, F equal to ma, a equal to how much, F by m, okay, this is. Now we need to break this part into two portions. Here is the diagram, this is one portion and this is one portion, its length is x and its length is L minus x, okay. You can take any one, you will get the answer same, right? So now, but its mass is not m, its mass you can take m1, its mass you can take m2, and right side force is F, and here at this junction you can assume, suppose T is tension acts backward because of back portion, at the same time same tension only acts on the back portion because of forward portion, okay na? So I am considering this part, right? So this part when I am considering, we can write net force equation. Total rope is moving right side with acceleration A. Then this also move right side with acceleration A. So then F minus T equal to M1A. But M1 do you know? No, we don't know. We need to find M1 value. For this, we need to depend on linear mass distribution, that is linear mass density. Linear mass density defined as lambda equal to total mass by total length. This concept you need to understand. Like how you have compared till now mass density, like volumetrical mass density, that is density equal to mass by volume you took. But in coming sessions you may have to take mass by length, mass by area also. Here mass per length is called linear mass density, which explains for total mass per total length is must to be equal to given mass by given length. So this is the ratio we need to compare here, that is total mass by total length is must to be equal to given mass by given length, which is m1 equals to mx by L. This is the answer we can get for m1. So we can put up m1 value here, okay na? So that is equation 1 you can take. From equation 1, F minus T capital Mx by L, acceleration equal to how much we got? F by M, m cancel. So T equal to F minus Fx by L, which is F taken common 1 minus x by L. This is the value of tension which acts at the point x distance from the applied force end, okay. So this is the way only they can ask you questions mostly, and this is one method to solve. Next, here is the question. Here again rope with mass is there and here mass of block M, and it is connected for the rope and it is being pulled with a force F. Then they are asking what A block is placed on frictionless surface in a gravity-free space. A heavy string of mass m connected and force F applied on the string, then tension at the middle of the rope. And they are asking at this point what is the tension. Okay. So at this point they are asking tension, how much tension, right? So you just understand one thing. At this point till now we need to break. Okay, now just now we have seen, again we will solve. First of all, total force equal to total mass capital M plus small m into acceleration. Acceleration equal to F by m plus m. This is answer. Okay, acceleration answer. Now they are asking tension at the midpoint. So what we do is, so we need to take first free body diagram like this portion, and you alone take this portion, you will get the answer. Alone this entire portion you can take, you will get the answer. Okay na? So here it is pulled to the right side tension, here it is pulls left side tension, here right side force. I am taking back side portion. This is front side portion also you can take to solve the answer. Okay, no problem. Same answer will come, no different answer will come. Okay, so now here this is exactly midpoint. Total mass present for total length is m. Suppose L by 2 length how much now? M by 2 only, na, definitely. And its part also m by 2. So now what we do is, here m by 2, m by 2. Okay. Now both the masses are same or different in the question. A block is placed, not given mass, so we can take capital M and small m only. And just I am writing here its mass is m by 2. Its mass is m by 2, being it is midpoint, so it is L by 2 length, it is also L by 2 length. So we can take a half length, half mass, half length, half mass, it is distributed. Because uniform distributed bodies only we will discuss here. Okay na? So now back portion here we can take, here it is capital M. So in this entire portion is being pulled with force, what? Tension. So T equals to capital M plus m by 2 into acceleration. So acceleration value we know already, capital M plus m by 2 into F by capital M plus m. This is the tension. Why I need to choose this one means, because very easily we can solve this answer. Okay na? Here you need to value substitute and take the LCM and simplify the answer. You get the same answer only, no problem. Okay na? So this is the way we can solve for the question. Right. Thank you.